Again, welcome to the PLC Professor's Workshop and Lab. This is where we develop all of our lab projects. And welcome back, actually, since this is part 2 of M38, which is the lab project where we are controlling 3 compressors and we're budgeting how much time each one of them runs. In the first discussion, we kind of did the layout of the overall project. In this one, we're actually going to go over the code that you did in the manual. And if we do a third part, if we run out of time doing the second part and we want to do a third part, it will be on some of the enhancements that you might do that go well beyond what we did in the manual. So let's look at the code that you did in this project in the manual and discuss it. Now, I'm not going to do step by step, drag this instruction down, go to the global variable database and, define this tag. I'm not going to do all the basic stuff. That was back in part 1, in the first semester, part 1 of the 3rd edition. So if you didn't do part 1 and you're starting with this lab project in part 2, 3rd edition, you're starting in the wrong place. Because we're not going to repeat all the stuff that we did in, 15, 16 hours of lectures and a dozen or so lab projects, including all the communication setup and all that. So let's go look at the actual code in all of those program files that we showed you in the previous discussion. You can see that we have the program running, and we have the simulator up there, and we showed you some of this in the last discussion. You can mouse over. Now, if in the third discussion, if we get that far, we may add some analog modules, and then instead of doing a pressure switch, remember 16 is low plant air pressure and 17 is low. We may replace 16 and 17 with an analog input module coming from an analog output module, and then using math and other instructions in our code to take the analog signal in from a pressure sensor and come up with those same 2 values. Obviously, you can do a lot more with an analog signal than you can with a digital signal. So let's begin here with the first program in our Micro850 structure. Now remember, this is a Micro850 simulator, but it could be a real Micro850. And you see up here, we have, it says exit Micro800 simulator. That's because we are running it right now, and this means that the power is on. As you can see over here, the power is on. Now you can go look at your configure IO wiring chart while you're running, but you're going to find editing it or modifying it quite difficult, if not impossible. So let's start with our first program. Remember that our first and last execution, the first needs to be buffer inputs and the last down here, buffer outputs. Now we put the HMI program file below the rest of them as a matter of habit, because it really doesn't matter where it's at in the sequence, but we want buffer inputs first, then we want systems. So over here is buffer inputs. I'm going to scroll down and you see that we're buffered all the way down to input 27. So 0 through 27, that's 28 inputs. And you can see that input 21, 22, and 23, those are the ones returning from outputs 11, 12, and 13 in our execution code. So that's buffer inputs, buffer outputs. We are buffering output 0, or rather I should say OUT00, which is the actual bit in memory that we write to, or we would for a fault indication. Now we're not actually using fault indication, so if I toggle on that, you see it goes off because there is no code that is driving output 0. That just got left on from something else. Okay, so you see output 0 here is now off down here. And So we're actually using, if you look down here at the bottom, we've got output 1, 2, 3, 4, and then 11, 12, 13, 16, 17. So if we scroll down through here you can see 11, 12, 13, and then you can see 16, 17. Okay, that takes care of buffer inputs, buffer outputs. So let's go to system. System is the part of the program that's kind of running the front end. Now, because I'm not taking you through the step-by-step development process of how I thought out the code, I'm just showing you the code and explaining to you what it's doing. You would not have started this program file with rung 1, not compressor A complete, not B, and not C. And if none of them are complete, then select initial primary. This is done to select A as the initial primary. Now you can't see that here, but if none of the compressor budgets are complete, then this bit's going to be on, and you'll see this bit in the sequence program file actually do something. So let's look at input 0. If it's off, as a matter of fact, I'll just turn it off. I went over here to the simulator and turn it off. Now you notice everything's dead. And now let's turn on, let's say, input 1, which is an override. Because I have input 1, the override switch on, I cannot change the mode. In other words, if I go over here, if I turn on input 0 here, input 0 goes on, but notice that I have no mode now because input 1 is on, so both of these rungs are false. And when I switched it over, I knocked it out of manual mode, and now I can't get back into either. Okay? See, I can turn it on and off. I can't get back into either mode. I have to turn off input 1, so none of the override switches are on. Now I can go back and forth between auto and manual mode. That's what we're doing there. And you see we have CLN logic. So if I'm in manual mode, which I am right now, I just turned 0 off. Okay, I'm in manual mode, right? I can turn, if I turn input 0 on, watch what happens. See, this rung goes false. Well, I went to manual mode because I had input 1 off. So let's go back and do that again. Let's turn input 1 on. So I have an override switch on. Now I'm going to turn input 0 on, and notice that I lose my mode now. I don't have manual mode or auto mode, because if you try to change mode with an override switch on, you're going to lose it. So we'll turn that back off, and it automatically goes into auto mode. Okay, because we had this switch on. Now if you wanted to change that, in other words, if you want to add code that prevents you from getting back into a mode without having all of the switches off, including 0, you could add that. So that's an enhancement for you right there. I'll do that again. We're in the auto mode. We'll go back to the manual mode, and we'll turn on input 1, which is this override. See, this went false, but we're still in manual mode, right? Now I'm going to go to select auto mode, but I don't go into auto mode, and I don't have any mode. Now if I turn this off, notice it jumps right to auto mode. You may not want it to do that. So we'll leave it like that for right now, but there's an enhancement that you could do to write code. So if you find yourself in that situation, you have no mode. So you could do that true if off manual mode and true if off auto mode, which would be this situation right here. Okay, true if off manual mode and true if off auto mode, then you could inhibit this section of code right here, so you can't go into auto mode. We'll just go back into auto mode and continue on. Now this run right here, when compressor C budget is complete, it resets all the code. Now there's two things to reset. I have a set bit for compressor A, B, and C complete, but I'm using just straight up coil for these reset bits. So we'll get to that later. But for right now, all you need to know is that if compressor C budget completes, it clears all this. You see, A is complete, B is complete, and within a few seconds, compressor C will be complete. You'll see it's all going to reset. There you go, reset. And now after whatever the budget is for A, then this bit will go back on. So let's jump to compressor A. Okay, we're going to skip sequence and production, and we'll go right to a compressor. Now I'm going to have to expand this out. I'm going to redraw this. As a matter of fact, I'm going to redraw this code and then come back to it. So I'm going to pause, redraw the code because it's so wide. In other words, this is fine if we're not trying to do what we're trying to do here in class. Okay, so you can see the whole thing here. If I've got A enabled and the production pressure is going on and off, I'm accumulating the time that compressor A is charging with an RTO. Okay, and this has nothing to do with cycling the compressors. That's in the sequence. This is accumulating the overall total run time. So you see I have 1 hour, 22 minutes, and 32 seconds. So I have accumulated, in the course of just playing around with the code here, 1 hour and 22 minutes of runtime at 12 seconds per cycle for compressor A. Now what I'm doing with that is, and this is an enhancement that I mentioned in the first video, we're not doing this in the manual because I didn't want to use up more paper and pages. So what I'm doing, I'm saying if the runtime, that's the total runtime, not the budget time, but the total runtime, if that exceeds 1,000 seconds, now we're running this for 12 seconds for our budget. So pretend like this is a day then, or let's make this a week. If this total runtime for A is greater than a week, then it says maintenance on compressor A 1,000 shutdown. So in other words, it's a indication to maintenance that it's time to shut down A and do some preventative maintenance. And then we keep on accumulating time on A, and then we have a 2K shutdown. That would be, in this case, 2,000 seconds. Okay, which we're way past that now. So if I reset this, you would see that these 3 bits, maintenance A, 1K shutdown, 2K shutdown, and rebuild, they would be false. So what I'm trying to simulate here is after X number of hours running, we want to shut down compressor A to do some preventative maintenance. And then after another length of time, shut it down again and do preventative maintenance. And then after some other length of time, we want to shut it down and rebuild whatever part of it that needs rebuilt, like piston rings or O-rings, whatever needs rebuilt. So this RTO here and this logic is an enhancement to the existing code. Okay, so all 3 compressors are the same. They all 3 have the exact same logic. But the primary logic for a compressor is if it's enabled, which C is enabled, and you get low pressure, then we turn on output 13 that says it's charging. So these 3 instructions right here, that is the entirety of the simulation of the compressor. We enabled it, we said there's low plant air pressure, and now we tell the other code that it's charging. Okay. So now let's go to production. And in production we have 2 timers. One to simulate low pressure to the system, and then there's another period of time where the pressure is not low. See, we're cycling back and forth, turning that low pressure output back to the controller on and off. But we're doing it very quick. You see, we basically have 1 second that the low pressure is on, then 1.5 seconds that it's off. Okay, so you see that this timer right here, not Q up here, this timer resets this after 1.5 seconds and it starts over. Okay, and then enable low pressure turns on output 17, and we're toggling this on from our HMI. So our code to simulate the production area are these two rungs right here, and that's all there is to it. Okay, now let's go to sequence. This is where the rubber meets the road. Now, when you wrote the logic, you did it in chunks. You did manual mode first, and I said this alone, these two instructions and enable compressor A was enough to run this in the manual mode. However, we also have an auto mode, and in auto mode we want to run compressor A, enable compressor A, if compressor A complete, the budget is not complete. See, true if off, compressor A complete. And here's compressor A complete down here. So if the unit is charging, and remember that unit A charging comes back from here. See? Right there. So output 11 is tied right here. See, it's tied back to input 21. So output 11 is tied to input 21 right here. So every time the compressor runs, output 11 feeds back to input 21 to an RTO that's set at 12 seconds, 12,000 milliseconds. And when it's complete, it sets this bit. Okay? So back up here. If you're in the auto mode and compressor A is not complete, then enable compressor A. Also, here's where we do our select initial primary right here. Remember back in system, right here. If none of them are complete, we turn on that bit, and that bit right there is on, so this is true. So when you go in the auto mode, it turns that bit on, and basically it selects it as the primary compressor unit. Now, if we've enabled A and we go to low production pressure, then we want to also enable this. So we'll get to that later. So here's the two rungs for compressor A, same two rungs for compressor B, same two for compressor 3. But you see the code is a little bit different. Notice that for C, it says if you're in the auto mode and A is complete and B is complete, but C is not complete, then enable C. Okay, and that's what we've got going on right now. And you can see that this is accumulating, hits 12 seconds, and resets. Okay, you never saw this really set because it was only true for one scan while it reset. Now we're back and we've enabled A. Now let's go to our HMI. This is the unique piece of code in this project, in that, and by the way, these no-op, this is just a global variable in memory that we're calling no operation. It's just a bit, and it's that bit is sitting all by itself in memory, doesn't do a thing, but it gives us a placeholder so we can complete the rung with an executable instruction. So this, each of these rungs says if it's true, turn on the no-op bit, but the no-op bit's not controlling anything. You see what I mean? It's just a placeholder so we can complete the rung. This is what we're looking at right here. Okay, so I have enabled consumption. This bit has nothing to do with the basic code of the system. What it does is it allows you to turn off the production area from consuming compressed air if you want to do some troubleshooting. So as long as we have consumption enabled, and by enabling consumption, so if we go to the production area, see enable consumption right there. So if we're in the auto mode, and this is true, I'll toggle that off. And I can toggle that off here or here. So remember, this is our HMI. So I can toggle on this bit right here, and I can toggle on this one. Okay, so I can't turn the switch on here, 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 or here. I have to go here to do that. In other words, if I want to switch input 1, 2, or 3, I have to do it right here by turning these bits on with the mouse right here. Okay, so the only two bits that I can control from this screen are enable consumption and enable low pressure. The rest of these are there for me to see what's turned on. Okay, so let's say I toggle this on. Now what happens when I toggle enable low pressure? That means we're going to have 2 compressors running at a time instead of 1. So if you look down here, you can see that we now, A was almost complete when I did that, and B was almost complete. So now they're both complete and C is running. So right now we've got B and C running. Right now we've got A and B, see, A and B charging. We let them run for 12 seconds. And now you see that we have B and C running. Actually, we have A and C running because B was already complete and we never reset it. So right now we have A and C charging. Now, once they're all complete, unless you do a reset, then you're going to see the same behavior, but you're not going to see, oh, it reset. Okay. So you see A and B charging together because we've still got enable low pressure. If I toggle that off, now you see just A is charging. B is not charging. Now it is because A is complete. So we're back to 1 at a time. So that, folks, is the basic code for this project, including the bonus code if you want, and that was in our compressor. We had this code that uses comparison instructions, and it compares against some longer length of time to shut down for maintenance or for rebuild. And of course this code, the HMI. So here you can see that we're enabling A is charging, and we're counting up. The budget is complete, so this goes complete. Now we're no longer enabling A. Now we're enabling B, it's charging, and so forth. So you can see the whole system here. It doesn't take that much work to write this little bit of code, because this type of code helps you greatly when you're troubleshooting. Now if you got a panel view, well then you can get your panel view working and you don't need this. But if you don't have a panel view, this type of code is really handy. So let's leave it here, and maybe we'll come back for a third run and talk about some other enhancements. But for right now, we're going to leave it here for M38 lab project, the 3 compressors.